Next question. You are given two particles of masses m1 m2 placed at a distance d apart or at rest. So two objects are there. Here one object, here one object, masses m1 and this one mass m2, separated by the distance of d. So they gave the entire distance between them as d. A third particle present on the line joining the stationary particle experiences a zero gravitational force. So some third particle will be placing here. So I'll consider the mass of the third is small m, so that the force experienced is zero. So we need to find the distance of third particle. So this distance we'll consider r. So the r will be need to find. So here two forces will be acting. First one will be F1, the force between m1 and small m. So the formula will be G m1 m divided by the distance is r square. Okay. And the next one will be the force between small m and m2, here and here. So for that, force 2 is equal to G, the masses m2 and small m, divided by the distance. How can we measure this distance in the sense? The entire is d, and then this is d minus r. So the distance is d minus r whole square. So the condition is net force is 0. Net force 0 means F1 equal to F2. By using this relation, we'll find out the distance r. So G m1 m divided by r square is equal to G m2 m divided by d minus r whole square. So here we can cancel G m can be cancelled. So here we'll get m1 by r square is equal to m2 by d minus r whole square. So we'll do certain relation, cross multiple here, d minus r whole square divided by r square is equal to here this side m2 by m1. Okay. So next I'll write common here, d minus r divided by r. So all bracket as square equal to m2 by m1. Okay. So in the next step, I can write d by r minus r by r, that is 1, whole square is equal to m2 by m1. So I'll do the next steps here. Squaring on both sides, we'll get d by r minus 1 is equal to, this side will get square root m2 by m1. Okay. Now I'll take this minus 1 to other side. D by r is equal to square root of m2 divided by square root of m1. So the minus 1, if it reach here, it will be plus 1. Now taking LCM, d by r is equal to square root of m2 m1 divided by m1. We need to find r only, so taking reciprocal, so r by d is equal to square root of m1 divided by square root of m1 plus square root of m2. Okay. Then we need r only, so take d other side. So r is equal to d square root of m1 divided by square root of m1 plus square root of m2. So when we place an object at the distance of this one, we get the net force is 0. Thank you.